Hey, ladies and gents, today we are going to learn how to solve a quadratic equation, an equation that has that highest exponent of 2 in it, without looking at a graph. Thinking back to when we've solved any equations in class, the first thing we do is go to the calculator. We look at the calculator, we look at the table, we look at the graph. Well, you're going to quickly re-go over how do I solve a quadratic equation on a graph. That would have been the lesson you just did on Monday. But we're going to review that really quick. But then we're going to move into how do I do this algebraically? What if I didn't want to use the calculator? Then how would I solve this equation? I'm going to show you I'm going to show you one of the ways. So there's some issues that we will encounter as we explore these quadratic equations that not every method for solving algebraically will always work. Today, though, good news, we're only going to focus on one of those algebraic methods for solving an equation. So we are going to be working on 22.8 out of your workbook or on Agile Mind. If you want to log in online, my course is on top. Unit 8. Down arrow next to topic 22, down arrow next to lessons, and we are going to be down here on lesson 8, the geometry and algebra of square roots. I will tell you that if you are going through the online slides, we are not doing everything, and you'll notice that if you access the online activity book and if you have your physical activity book. Just a reminder, once you're online and you are under Unit 8, Topic 22, you can click Activity Book right here, and if you don't have your book at home, you can follow along with us. If you do have your wonderful activity book, we are starting on page 293, page 293. So I'm actually going to leave my screen up here real quick because this is the opener that is in your workbook, and I also want to access my calculator. Again, if you have not figured out how to download this calculator onto your or how to access it on your school issued computer, there is a Canvas module that explains how to do that. This is the exact same as the yellow calculators you used at school. So we have the quadratic equation x squared equals 36. Now we know it's quadratic because of that highest exponent of 2. And we want to solve it in our calculator. So we really have two different ways to do this. The first way is very similar to how we solved linear equations. We go to our y equals, which I'm there already, and we type the left side of the equation, x squared, into the calculator in the y1, and then going down to y2, we are going to type the right side of the equation, 36, and we are going to hit graph. We know that where the two graphs intersect, that is going to represent, it's a problem. Where's my other? 36, duh. 36 is not going to be on the screen. We know where the two graphs intersect is going to represent the solutions for my equation. So 36, again, the right side of my equation right here, 36, we're not going to see that. I don't know why that took me a while. So I know that I need to increase my y values because it was a y value of 36. So I hit window. I'm going to go down to y max. I could type in exactly 36, but that would push right the top of my screen. So I'm actually going to type in 40, hit enter, and then I am going to graph. There is x squared, there's my parabola, and there is a solution, and there is a solution. So now I have to figure out, okay, what is that x value? I can hit second calc, and I need that point of intersection, number 5. I'm going to hit enter. I'm going to hit enter. And this time, notice there's two places where those two graphs intersect. I'm going to get a little closer to focus on one of them. I need to kind of direct my calculator, which one do I want first? I'm going to hit enter. It's positive 6. If I do it again, the other one is negative 6. So there's one option for solving in our calculator. The other option, think back, and now, actually, no, I'm not going to flip over my screen quite yet. Actually, you know what? I will. I'm going to flip over so you can see my workbook. I'm going to show you some notes from the last time we talked. Whoops, there we go. Sorry for the technical difficulties. So we said when we're solving a quadratic equation based on the graph, we know that that is where the equation is equal to 0. That's where the equation is equal to 0. Notice this equation does not say negative x squared equals negative 4. If it did, then I could put the negative x squared in y1, the negative 4 in the y2, and I could move from there. This equation is equal to 0, as is the equation over here equal to 0. So what are some benefits of being equal to 0? Well, think about the issue we just had in creating this graph. Our y value was 36. Now, many of you are really, really comfortable with adjusting your window, which is fantastic. But if you're not comfortable adjusting your window, then one way around that, if we always want to solve an equation by looking where does it equal 0, then we have to make our equation equal to 0. So I'm actually sorry for the flipping back and forth. I'm going to flip this over. And we don't want that. We want this. Here's that x squared equals 36. If I make it equal to 0, I don't have to worry about the, I'm just going to rewrite the equation. I don't have to worry about the window. I can leave my window, if you will, normal. So how do I make this equal to 0? Well, the easiest thing I can do is subtract the 36 from both sides, because 36 minus 36 is 0. And we have x squared minus 36 is equal to 0. Now, when I go to my calculator, I'm going to bring that up here. I'm going to go to my y equals. I'm going to change that y1 to x squared minus 36. I am going to clear out that side. I'm equal to 0. I don't really need to type in 0 because I know being equal to 0 means finding an x-intercept. I'm going to hit zoom 6, which moves my graph or moves my window back to normal. It'll eliminate that 36 we had before. And we're going to take a look. I now see that I have two places where my graph is equal to 0. Now, I notice here that these are hitting at really, really nice places. So I could keep hitting this side arrow, and I can count that tick mark should be 6 and the other tick mark should be -6. But as we did last time, you could also hit second, calc. We know another name for x-intercepts or solutions are zeros. So I'm going to go option 2. Remember, you need to be to the left of one of your x-intercepts. As soon as you are, hit enter. As long as the x-intercept in question is to the left of, or as long as that line is to the left of the x-intercept in question, you are good to go. I need to be to the right. It doesn't matter how far. Hit enter. As long as that line, as long as those two vertical lines are sandwiching your x-intercept, you're good. I'm going to hit enter as a guess, and there we go. I get an x of 6, and if I were to do this again, the left side would be at -6. So I might as well go through it again. Second calc number 2. Becoming a left bound for that far left one. Again, the reason we have to sandwich these, the reason we have to do this left bound, right bound, is because there are more than one solution. So we have to indicate to our calculator which solution we are dealing with, which one do we want. Why is it that we have to tell it when we want both? There's going to be some situations where you only want one. Only one makes sense. So that's why we have to do one at a time and indicate which one we're talking about. So left bound, hit enter. That line shows up. Right bound, hit enter. And I'm not even going to move it. I'm just going to guess. And you got it. We got -6. Now, all that work just for 6 and -6. Now, so many of you like your calculators, and you are totally okay with those calculators. Sometimes I find it easier to actually see myself when I'm talking. But algebraically, how do we do this algebraically? Because I'm going to let you in on a secret. In some cases, some, not all, in some cases, solving these equations algebraically is actually easier than taking the time to go to the calculator. So today we're going to focus on method number 1 for solving a quadratic equation algebraically, meaning by hand, and that is using square roots. So again, we're staying on page 293 in your workbook. Really? No, this is the only page we're going to do in our workbook today, so it's a short lesson today. So here we go, page 293. And we want the camera view. There we go. Page 293. Solve x squared equals 9 using square roots. Well, why square roots? Everything in math we know has a way to undo it. Addition, its way to undo it is subtraction. Multiplication's way to undo it is division. Well, how do we undo an exponent of 2? To undo an exponent of 2, we use its inverse operation technically, not opposite, but if you say opposite, I'll be okay with it. We use a square root. Okay, so here we go. I see something squared. I'm going to square root it. We know adding cancels out subtraction as long as we're adding and subtracting the same number. Squaring and square rooting are going to cancel each other out. So they're going to cancel, leaving me with an x. We also know in solving an equation, whatever I do to one side, I do to the other. The square root of 9 is 3. Okay, that wasn't too bad at all, was it? Now it does say check on your calculator. So before I go to my calculator, I'm going to focus on the fact that we have x squared equals 9. Again, I could put this in y1 and y2, but I don't want to have to potentially worry about adjusting my window. So instead, I'm going to focus on finding the x-intercepts. And in order to do that, I'm going to make my equation equal to 0. And then I only have to type in 1 y equals, and I'm only looking for my x-intercepts as my solution. So here we go. In my y equals, I'm going to go to x squared, and I'm going to turn this into a -9 and graph. And again, we want our x-intercepts, and you can probably count the tick marks. Yes, this seems to make sense. By square rooting, we got 3, and there is our 3 right there. But hopefully something else sticks out to so many of you. Highest exponent of 2. We know with these quadratics, sorry if you see my finger twitching in the bottom corner. I am tapping on the arrow key on my calculator. It's weird how my reflector camera works. I also have a solution or an x-intercept of -3. That didn't show up algebraically. It shows up on my calculator, but not algebraically. Well, here's something you need to remember. Anytime we square root, we get both a positive and a negative answer. 2 answers anytime you square root. I'm going to make a note here, and yes, I will put up a copy of my notes here. 2 answers every time you square root. Every time you square root. 2 answers every time you square root. 1 plus and 1 minus. Now, another way many of you have probably seen this written is +3 and -3 can be written like this, both positive and negative. This is called a plus and minus sign, a positive and -3. Excuse me. Now, why is it that you get both a positive and a negative anytime you square root? Well, think about what a square root symbol says. A square root symbol, so let's go with the square root of 9, is saying what number times its identical twin gives me 9. That's what a square root is asking. What number times its identical twin gives me 9? Well, I know 3 times 3 gives me 9, but at the same time, -3 times -3 gives me 9. 2 negatives make a positive. The downfall of the calculator is if you had typed in the square root of 9 in your calculator, it will never show that negative. This is one of those things you just have to remember. Anytime you square root, you get both a positive and a negative answer. Okay, so let's move on to the next 2. I see something squared. I could go to my calculator, but heck, we can save some time. I am going to actually, we'll write in here. I'm going to save myself some time. I'm going to square root to cancel out the exponent of 2. That gives me x. And then I have the square root of 2. And now many of you may be thinking, I don't know what the square root of 2 is. I could type it in my calculator, and actually we are going to do that right down here. You'll notice 2, 3, and 4 are really all the exact same problems. Square root of 2, go ahead and grab your calculator. Square root of 2, I'm going to quit out of there. To square root, you're hitting the blue button, and then the x squared button diagonal from the 7 gives you the square root. You should see that square root symbol in blue up there. Square root of 2, the reason that is not one that you just know off the top of your head is because the square root of 2 is what we call an irrational number. It is a decimal. You know the square root of 9 because it's a whole number, 3. You know the square root of 25, it's 5. Every number has a square root. we just only memorize what we call the perfect squares. So the square root of 2 is approximately, obviously I had to round, 1.41. But again, we always get 2 answers every time we square root. So I can either write it as this, positive 1.41 and negative 1.41, or I can write it with that symbol, x equals plus or minus 1.41. Now, you may see these answers written in 2 different ways. Some people, some math teachers, some assignments you do will do the square root of 2 and it will do the decimal approximation. Great. Some people will say decimals are messy. Technically, we had to round. So technically, this is not exact. So they will do exact values. Exact value simply means they leave it as the square root of 2. And I'm going to go ahead and remember 2 answers, both a plus and a minus in front. This would be the exact form. This would be the approximated form. Exact value, as I put right here, exact value means leave as a square root. Leave as a square root. And the approximate value means we are going to go with a decimal. Now, side note, not this year because of the situation we're in, but either next year in geometry or in algebra 2, you'll actually learn how to simplify square roots, reduce them kind of like fractions. But again, we're going to save that for another math class. No, you're not missing anything algebra 1 related. You're not at a disadvantage. It's just it's something they talk about in geometry and algebra 2 anyway. So let's do another one. X squared equals 8. Again, I could put this in y1 and y2. I could subtract the 8, make it equal to 0, and in either situation put it in my calculator, or I could do it the faster, easier way. Say, okay, to cancel out that exponent of 2, I'm going to square root. That leaves me with an x. Solving an equation, whatever I do to one side, I do to the other. And I recognize, square root of 8, that is not something that I know. 8 is not a perfect square. So leaving it in its exact value, I have both a positive square root of 8 and a negative square root of 8. Notice all these different ways I'm writing both the positive and the negative. I don't care which option you take. Moving down here to number 4, though, going for the decimal, I'm going to run through it again. We square rooted because it cancels out a square. And whatever we do to one side, we do to the other. I don't know what the square root of 8 is off the top of my head. So going to my calculator, the square root of 8 is approximately 2.83 using my rounding rules. It's approximately 2.83. So I have both a positive and a negative 2.83. Or again, you can write it with that plus or minus in front. Plus or minus 2.83. Now, how do I check these answers? How do I check that I did this correct? Plug it back in. I could take this 2.83 or this negative 2.83, plug it back in for x, square it, and I should get 8. So we're going to actually do that. 2.8, actually, parentheses, because anytime I plug something in, I should use parentheses. 2.83, I'm going to square it, and we should get an 8. Now, you'll notice we got just over 8. Does this mean we did something wrong? The answer is no, we didn't do anything wrong. Keep in mind, we approximated. We had to take that decimal that you can see in the line above on the calculator. We had to round that decimal. In rounding that decimal, the downfall of rounding is that it means when you check, your answer is not going to be perfect. Your answer is not going to be perfect, but it is super close. We know that we did this correct. Wow, Mrs. P, this was super, super, super easy. Okay, cool. Then let's try another one. We are going to flip the page twice. We are going to flip over to page 296. Page 296. Now, you'll notice in this case, you already have the answers. In a little bit, your homework today is going to be another Desmos matching. It's linked up here on Canvas. And you are going to match an equation to a graph to a solution. You're not going to have this classification thing. You're going to match up these 3. I just want to show you how these are connected. Okay, first, if I think about my general form for identifying transformations of a quadratic, I don't have any A. I don't have anything flipping my graph over or adjusting the width, so I can leave it. I'm good. My parabola is a normal width, if you will. I have no number in parentheses. This means I have no left and right movement. What I do have, though, is a down 36 units for my vertex. So my vertex normally would start here, but because there was no left and right, just a down 36, that's why my vertex moved here. One way you can identify the graph, and I encourage you to practice this, is to run through the transformations. Another way you can identify the appropriate graph is to actually graph it. You have calculators, go for it. Coming up with the solutions. Well, if you came up with the graph, we can see my solutions are my x-intercepts, where I cross the x-axis, where I'm equal to 0, 6, and negative 6. Another way I can come up with those solutions is solving by square roots. Now notice, in this case, I can't square root right away. Why? Because my x is not by itself. In order for me to square root, I need to isolate the x. That's everything we've ever learned for solving equations is get x by itself. So in this case, I'm going to add 36 to both sides, and then to cancel out that squared, I'm going to square root. And whatever I do to one side, I do to the other. And we know anytime we square root, we need both a plus and a minus. And the square root of 36, that's a perfect square, is 6, both positive and negative 6. I'm going to throw one more at you, just make one more up, and then I'm going to let you guys do some practice. So I am sorry for that. I'm just going to use this space down here. You don't need it for anything else. Let's go with, how about this? Negative x squared plus, what's a good number? 74 equals 0. Okay, negative x squared plus 74 equals 0. Things I recognize about my parabola. I don't have a number for a, but I have a negative. This means my parabola is going to open down. My parabola is going to flip over because it's negative. Next thing I notice, this is not in parentheses. It's not a left and right. This is going to be an up and down. My graph is going to go up 74 units. Wow, I'm not going to get exact right on here, but I flipped over because of the negative, and my vertex is going to go up 74 units. So I am going to just pretend that this is up 74. Perfect. Okay. So my solutions are going to be where I cross the x-axis. So it's going to be whatever this number is, whatever this number is. Sorry, I know that's really tiny. I'm going to go through and solve this using square roots though, but I need to get that x squared by itself. So first, I'm going to subtract 74 from both sides. And we have negative x squared equals negative 74. So are we ready to square root now? The answer is no, because we still have this negative. I can't square root this. I want x squared. I don't want negative x squared. So remember, this is a negative 1. I'm going to divide by that negative 1. Whatever I do to one side, I do to the other. Negative divided by a negative is a positive, so we get 74. And then to get the x by itself, I'm going to square root because square rooting cancels out that exponent of 2, and I'm going to square root the other side. Now, I don't recognize 74 as a perfect square. I do know anytime I square root, I get both a positive and a negative. So I'm going to go to my calculator. If I wanted to leave it in exact form, I'd leave it as the square root of 74. But if I want to approximate, I can go to my calculator, and I know the square root of 74 is approximately 8.60, meaning my x-intercepts, here we go, these numbers where I cross the x-axis, my x-intercepts, also called zeros, also called solutions, are at approximately 8.6. Now, next time we meet, which is on Friday, we are going to talk about some of the situations where you can't use square roots. But for now, I just want you to practice matching up the graphs, solving by square rooting, and on Canvas, it'll link you out to Desmos. Completing that is your homework. I will, since that is not linked into a Canvas assignment, once you complete that matching, give me a little bit of time, please, but look for an email from me, and I'll give you some feedback about that matching.